All right, today we're going to continue talking about exponential and logarithmic equations. So you're going to be doing applications, which is a fancy word of saying word problems. Read the problem, find the given function. They'll give you some function to represent the situation. Decide what the variables in the function represent, plug in what is given, and then solve what you're looking for. We're going to use logarithmic properties to simplify. So it says medical research indicates that the risk of having a car accident increases exponentially as the concentration of alcohol in the blood increases. The risk is modeled by this formula, where X is the blood alcohol concentration and R, which is a percent, is the risk of having a car accident. The question is, what blood alcohol concentration, so they're asking me to find X, corresponds to a 17% risk of a car accident. They told me the percent is the R. So I need to plug in 17% over here. So I'm going to put in 0.17 equals 6e to the 12.77x. Oh, sorry, I'm bad. It's given as a percent. So they're telling me that it's okay to use it as a percent. So I don't need to make it a decimal. Okay? So the problem is my variable is hanging out up there in the air. We've never been able to solve for x when it's in the air. You can solve for x if it's on the ground, but not if it's in the air. So how in the world am I going to get that x out of the air and onto the ground? Well, that's why we have logs and natural logs. The trick is to take whatever has the exponent on it with a variable in it and isolate it. So to get rid of times 6, I'm going to divide. And I get 17 divided by 6 is 2.83 repeating equals e to the 12.77x. Now, the trick is, when you have base e, like we have right now, to get x out of the air, you take the natural log. If I take the natural log of e, because ln has a base e, and we learned in our properties, once these match, they cancel. And I can do whatever I want as long as I do the same thing to both sides. So I'm actually also going to take the natural log of 2.83 repeating. So on this side, it cancels out, and the 12.77x drops, which is what I wanted. I wanted it out of the air. On this side, we can use a calculator. So you type in ln of, and you know what, instead of typing 2.83 because it's a repeater, I'm going to type 17 over 6. So natural log of 17 divided by 6, close my parentheses, is 1.0414538875. Again, I wouldn't write it all out every time, but don't round until the end. It really does. It's crazy how it affects your answer. So to get x alone now, I'm going to divide by 12.77, which gives me x equals, well, that's on my screen, divided by 12.77, x equals 0.08155547, yada, yada, yada. So basically it says that if your blood alcohol content is 0.08, which is barely the legal limit, 0.08 is the legal limit to still drive. If you have a 0.08 blood alcohol level, you are running a 17% higher risk of having a car accident. All right. Oops, skipped one. Yeah, there we go. Sorry. All right, so revisiting the model for height of children. It says, we've seen that the percentage of adult height attained by a boy who is x years old can be modeled by this function, where x represents the boy's age from 5 to 15, and f of x represents the percentage of his adult height. At what age, rounded to the nearest year, has a boy attained 85% of his adult height? So they're telling me that f of x is the percentage. So they want me to replace f of x with the percentage. So I change that side to 85 equals 29 plus 48.8 times the log of x plus 1. Well, at least x is on the ground, but I can't get x alone until I can roll the log. and I can't roll the log until it's all alone. So I've got to get rid of the 29 and the 48.8. So I get rid of adders and subtractors first. I'm going to subtract 29 from both sides, and I get 56 equals 48.8 times the log of x plus 1. To get rid of the 48.8, I'm going to divide. 56 divided by 48.8 is 1.147540984 equals log of x plus 1. Well, again, I'm trying to get x alone. When you have a log and you want it to go away, obviously I need it to go away so that I can get x alone, roll the log. And if they don't write a base, it's base 10. So when the log rolls over, the 10 moves over. So I have 10 to the 1.147, whatever. I'm going to round it a little bit. I won't round it on the calculator, but I'll round it to write it. I don't want to write all that out again. And on this side, the log is gone, the 10 moved over, and all that's left is x plus 1. So if I take 10 caret to the 1.147540984, I get 14.0456 blah 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 equals x plus 1. So now to get x alone, I'm going to subtract 1, and that gives me x equals 13.0456 yada 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 yada. And let's see, we're going to what age? Round it to the nearest year. So 0 won't do anything. Approximately 13 years old. The kid has reached 85% of his height. A boy. Okay. Alright, so you try this one. Hit pause. Come back when you're ready. And come on. There we go. Hopefully you got 180. Alright, here's my formula. And it says that it models the amount in pounds of a radioactive material stored in a concrete vault. So A is the amount in the vault. And X is the number of years since the material was put into the vault. It says if 500 pounds of the material are placed in the vault, how much time 500 pounds are in the vault initially, that's your A sub naught. This is the amount in the vault after the time has passed. This is the amount in the vault in the beginning. How much time will need to pass for only 84 pounds to remain? So they're telling me what A is, and they're telling me what A sub naught is. So if I plug those in, I want to know when 84 pounds are left from the initial 500 pounds. There's my A sub naught. E to the negative 0.0099x. And we have to solve this thing for x, which is in the air. So to get it out of the air, I'm going to have to throw a natural log at it. But I can't do that until I've isolated this. So I'm going to divide by 500. 84 divided by 500, I get 0.168 equals e to the negative 0.0099x. Alright, and to get that x out of the air, I'm going to take the natural log of both sides. On this side, if I type in the natural log of 0.168, I get negative 1.7837913 equals, on this side, those cancel, and I'm left with negative 0.0099x. So now all I have left to do to get x alone is divide by negative 0.0099. Cancels that, and x equals divided by negative 0.0099, and I get 180.18093994. If I round to the nearest year, the 1 won't do anything, so x equals 180 years. Alright, try this one, hit pause, come back when you're ready, and hopefully you got 28 years. It says the population of a certain country is growing at a rate of 2.5% per year. How long will it take for this country's population to double? Use the formula t, which is time, is ln of 2, the natural log of 2, divided by k, And it says t is time, k is the growth rate, which is always your percentage, to double. Okay, so there's my k. We're going to plug that in. I have t equals ln of 2 divided by, this one I do believe we have to make it a decimal, 1, 2, because it doesn't say in percent. So this would be 0.025. So to solve this thing for t, we just type that in. And t is already alone. So we type in natural log of 2. Make sure you close your parentheses. Divided by 0.025. And I get t equals 27.72588, blah, 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 blah. To the nearest year, the 7 would round it up to 28 years. Alright, we've already talked about our formulas for compound interest. Why are we talking about them again? Well, before when we did these, you were always trying to figure out A. It was pretty nice and easy. You just typed everything in the calculator. This time, they're going to give me A, and they're going to ask me to find maybe the principal or the rate or the number of times it's compounded or the time. That's the difference today. Alright, so they give me the formula A per naught again. It describes the accumulated value A of a sum of money P, the principal, after T years at a rate R in decimal form, compounded n times a year. It says how long, so I'm looking for time. Will it take 25,000, that's my principal, to grow to, that's my final amount, 500,000, at 9% annual interest rate, which is 0.09. And it's compounded monthly, so n is 12. So if I plug all those in, I know A is 500,000. My principal is 25,000. 1 plus my rate is 0.09 divided by 12 to the 12 times t. That's what I don't know. So I can already tell that the variable I'm trying to solve for is in the air, which means I've got to get it down, which means I've got to get what the base is alone. So the first thing I'm going to do is divide by 25,000. Alright, those are gone. And I take 500,000 divided by 25,000, and I get 20. So we got 20 on this side equals, and I'm going to go ahead and type in what's in parentheses. So 1 plus 0.09 divided by 12 is 1.0075 to the 12t. Okay, so we got that all simplified. Now to get t out of the air. Well, remember when we were trying to do the ones with E, to drop it like it's hot, to get it out of the air, we used the natural log. Well, here we don't have base E, we have a different base, which all that means is we need to log both sides instead. So if I log 20 and log 1.0075 to the 12t, now I can drop it like it's hot. So I'd have log 20 equals 12t times log 1.0075. Now t is on the ground. So to get t alone now, I'm going to first divide by the log 1.0075. Log 1.0075. That cancels. That gives me 12t equals, and if I type that in, log 20 divided by log 1.0075, I get 400.92697, blah, 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 blah. Divide by 12, and I get time is 33.4105888. What did it tell me to round to? How long will it take? It doesn't say, so it's going to take approximately 33 years. Huh. That'd be kind of cool. Alright. Cindy will require $14,000 in 2 years to return to college to get an MBA degree. How much money should she ask her parents for now so that if she invested all at 12% compounded continuously, she will have enough for school? Round your answer to the nearest dollar. I heard the word continuously. That means we're using a per. So Cindy will require $14,000 in 2 years. So that's the amount that she needs in the end. So that's my A. My principal is what they're asking for. How much money should she ask her parents for now? That's the beginning amount. So I'm solving this for P. E stays E. My rate is 0.12. And her time is 2 years. Okay, so the first thing I'm going to do is take 0.12 times 2. And that should be 0.24. So I have 14,000 equals PE to the 0.24. Alright, so to get P alone, I'm going to divide by E to the 0.24. So my principal amount that I need right now is 14,000 divided by E caret 0.24. Wait a minute, let me use parentheses. 14,000 divided by parentheses. I don't know if it makes a difference. I just don't trust the calculator. E caret 0.24. No, we're good. So the principal amount she needs is $11,012.79. If she can ask her parents for that and stick it in a bank, she'll have her $14,000 in 2 years. Okay? Alright, hit pause, come back when you're ready. And hopefully you got 10 years. Alright, so it says find out how long it takes a $3,000 investment. Investments are always P. To double. That means A is going to be 6,000. He's being kind of a jerk. He's telling you but not telling you. He wants your investment to double. That means in the end you want your amount to be 6,000. If it's invested at 7%, that's your rate. Compounded monthly means N is 12. And it says round to the nearest tenth of a year. So if I plug in what I know, I want 6,000 when I'm done. I'm starting with 3,000. 1 plus my rate is 0.07 divided by 12 to the 12 times T. Because that's what they're asking for, is how long is it going to take to double your money. Well, I don't know why that line is so long. I am going to first divide by 3,000, which gives me 2 equals, I'm going to type what's inside, 1 plus 0.07 divided by 12. And I get 1.00583 repeating to the 12t. Again, I need to get t out of the air, and it's not base e, so I'm not going to ln both sides. I'm going to log both sides. Now I can drop it like it's hot. So I have log 2 equals 12t times log 1.00583 repeating. So to start to get t alone, I'm going to divide by log 1.00583 repeating, log 1.00583 repeating. So if I do log 2 divided by log 1.00583 repeating, I get 12t equals 119.1714686. To get t all the way alone, I'm going to divide by 12 now. Divided by 12, and I get t equals 9.9309, blah, blah, blah. Ooh. If I round to the nearest 10, that's going to be 9.9 years. My bad. That's wrong. Again, unless I rounded funny. If I rounded funny, it could affect your answer. Man, that 9.9 and 10.0, that's really close. That's not a good idea for a multiple choice answer. Alright, Larry has, hit pause and try this one and come back when you're ready. Hopefully you got 3. It says Larry has $27,000 to invest and needs $3,100 in 12 years. So this is what he's starting with. This is what he wants after 12 years. What annual rate of return will he need to get in order to accomplish his goal if interest is compounded continuously? So they're asking you to find the rate, and they're telling me to use APER. So if I plug in what I know, the amount I need at the end is $3,100. I'm starting with $2,700 times E to the rate, which is what I'm looking for, in 12 years, so times 12. So again, I need to isolate so that I can ln it. I'm going to divide by 2,700. 3,100 divided by 2,700 is E to the 12R 1.148148148, so yada yada yada. Alright, so now I'm going to take the natural log of both sides, ln of 1.148, repeating, equals ln of e to the 12r. On the left-hand side, type it in the calculator. The natural log of that answer is 0.13815, blah, 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 blah. On this side, they cancel out, and I get 12r. Yeah? So now if I divide by 12, my rate is divided by 12.01151252282. Now, when you're looking for a rate, you're looking for a percentage. The formula will give you your answer in a decimal form. To change a decimal to a percent, you move 2 places to the right, and that's where they got their 1.15%. Okay? Alright, so how do you solve exponential growth or decay functions using inverses? How do you solve exponential growth or decay functions using inverses? Well, like we just did, to get rid of e, we use ln. To get rid of anything else, you can log both sides or use the log, which would roll to 10, either way. Alright, so we're at homework, so that's good. So happy homeworking, and I will see you next time.